Billions of years ago, our solar system was a chaotic place. A swirling disk of gas and dust, left over from the birth of our sun, slowly began to clump together. Today, we'll zoom in on the story of one particular clump, a rocky world destined to become the red planet, Mars. The leading theory for Mars formation is called the core accretion model. Imagine this swirling disk around the young sun, like a giant pizza. Gravity started pulling these particles together, forming tiny pebbles that eventually collided and stuck, growing into larger and larger bodies called planetesimals. Mars wasn't alone in this celestial game of bumper cars. Numerous planetesimals were vying for dominance. Through collisions and mergers, some grew into planets, while others were shattered or simply left behind as asteroids and comets. As Mars grew larger, its interior began to heat up due to the decay of radioactive elements and the crushing pressure. This heat caused differentiation, where heavier elements like iron sank towards the center, forming the core. Lighter elements like rock formed the mantle, and even lighter elements like silicates rose to form the crust. Early Mars likely had a magnetic field generated by the movement of molten iron in its core. This magnetic field would have protected the young planet from the harsh radiation and solar wind blasting from the sun. With its hot interior, Mars likely experienced a period of intense volcanic activity. Volcanoes spewed lava flows across the surface, potentially contributing to the formation of Mars's iconic reddish hue. These eruptions may have also released water vapor into the early Martian atmosphere. The search for water on Mars is a major focus of space exploration today. Evidence suggests liquid water once flowed freely on the Martian surface, carving river valleys and filling lakes. Where did this water go? Some theories suggest it may be frozen underground as permafrost or locked up in the polar ice caps. Over time, Mars's core cooled and solidified. This likely led to the decline of its magnetic field, leaving the planet vulnerable to the relentless bombardment of charged particles from the sun. This solar wind is thought to have stripped away much of the Martian atmosphere, leaving the thin, cold atmosphere we see today. Today, Mars is a cold, dry desert world with a thin atmosphere. Its surface is scarred by ancient volcanoes, vast canyons, and polar ice caps. However, the Martian landscape is not static. Wind-blown dust storms rage across the planet, sculpting its surface and reminding us of the dynamic forces at play. The story of Mars is far from over. Rovers like Curiosity and Perseverance are exploring the Martian surface, searching for signs of past life and potential resources for future human exploration. Mars may hold the key to unlocking the mysteries of our solar system's formation and the potential for life beyond Earth. So, the next time you gaze up at the night sky and see the red planet glowing faintly, remember the incredible journey it has taken. From a swirling cloud of dust to a volcanic world with flowing water, Mars is a testament to the power of gravity and the ongoing story of our solar system.